All right, so today's session is called Advanced Mocking for Swagger APIs, Speeding Design and Development with Virtualization. We're going to show you a couple of awesome tools here with Swagger and Swagger Hub, as well as Service V Pro. So just before we get started, I want to introduce everyone. We've got a great group of panelists here. Harsh Apredi is our product marketing manager, and he'll be walking us through some of the slides today and kind of presenting an overview of everything from mocking and virtualization. And then we've got Nathan and Mike, who are our two engineers. Nathan's going to be walking us through each of the tools, and Mike will be on chat answering any questions that you have, so definitely be sending those in. And my name is PJ Stevens. I'm the marketing manager for SOAP UI and Ready API here at SmartBear. Before we jump into the agenda, I just want to give a quick plug for SmartBear Academy. This is our user conference that's happening in Boston, September 12th and 13th. We've got a bunch of awesome sessions and speakers lined up. Product folks, industry experts like Ule Lensmar, who's the creator of SOAP UI, and the leader of the OpenAPI initiative. And we've got great API testing and API design tracks as well. So lots of really valuable content there, and we hope you'll check that out at smartbear.com/connect2017. So a couple quick housekeeping items. The session is being recorded, and we'll send the replay out via email later this week. So stay tuned for that. As we go through the session, please don't hesitate to submit any questions through your GoToWebinar question portal there. And Mike will be over there responding, as well as Nathan and Harsh here. And we'll try to answer all your questions. We want to make this as interactive as possible. And then at the conclusion of the webinar, there's a quick survey. So we appreciate your feedback as we try to improve these going forward. So with that, I'll kick it over to Harsh to walk through the agenda.
Thanks, PJ. Hi, everybody. Good morning, good afternoon, depending on wherever you are in the world today. And today we have an awesome line of tools that we are presenting in front of you. And it is all centered around the OpenAPI specification. So OpenAPI specification is a very popular specification being used by API designers and developers all over the world. And what we wanted to do today was kind of present an idea in terms of how do you get the most out of your designing capabilities from OpenAPI spec, also known as the Swagger spec, most recently before OpenAPI 3 came out. So we know that a lot of times when we are designing and developing APIs using Swagger, we use mocking and sandboxes for our development and testing purposes. There is a need for designers to present a version of their APIs to their consumers. So we will be using the concept of API designers, developers, and API consumers, and we will see how mocking helps you to some extent in doing that, in taking your OpenAPI designs to your consumers. But also there is another point that it is not sufficient. Mocking gives you a way of doing it, presenting your APIs to your consumers, but at the same time, your consumers are limited to maybe 1 or 2 responses because it's so much limited. Same goes for sandboxing. So we thought that we would try to present an idea here to kind of solve that problem for you through virtualization. We will look at how currently when you do API design and development through Swagger or OpenAPI specification, you use mocking, and what are the problems with that. And then when we introduce the concept of virtualization, that is primarily advanced mocking, sophisticated mocking, a lot of ways people try to explain the concept. We will scratch the surface of virtualization a little bit and see how you can take this new concept of service virtualization for your API design and development and provide better quality APIs to your consumers. And so I promise you it's not going to be all PowerPoint slides. This is just to set the agenda. We have 5 to 6 or maybe 7 slides today. To kind of set the concept right, and then later on Nathan here is going to do an awesome demo with a bunch of tools that includes Swagger specification, Service V Pro, and Swagger Hub. All right, so before we begin, a little plug for the OpenAPI specification. So what is OpenAPI specification? Well, I think everybody here who has joined the webinar has come to learn more about Swagger and virtualization. So you already have an idea about it, but it's worth mentioning to the people who are new to the concept. So it's a way of representing a contract between producers and consumers of APIs. So it's a way of representing it. It's very easy to understand for humans as well as for machines. And it's a specification that lets you design and develop APIs independent of any language, framework, or technology. You don't have to be familiar, or you do not have to have certain context in maybe Java or XML or JSON. That knowledge is not required if you are an API designer. If you just want to present you want to share your concepts with your consumers in terms of APIs, you can do that in very much plain English. You can see on the right side of the slide that you can describe using description tag and required, whether some parameter is required or not. You can express your APIs very cleanly in this format. The OpenAPI specification supports primarily, and we evangelize this at SmartBear, that we want you to think about, design first approach, the API first approach. That means that we want you to think about your API design holistically, and before you commit to even a single line of code. And this is going to be the theme of our presentation today. We're going to be telling you that how can you reinforce and develop your design and make them better and better before you even write single line of code, and how can virtualization help you do that. So we don't want you to develop your APIs and then give it to your consumers. We want you to design and reinforce the design, iterate over the design again and again before you even spend a single dollar in terms of development of your APIs. OpenAPI specification is very much community driven, and it's evolved over the course of years with support from everybody, from a bunch of companies, from a lot of people, especially around the Swagger tooling. So swagger.org, swagger.io is a website where we have all of our Swagger tooling. A bunch of people have supported this initiative with a lot of enthusiasm. And it's very much community driven. And if you are looking for developing APIs, if you have an API concept, if you have APIs right now, and if you want it to be more standardized onto a great set of tooling, then you should try to look at OpenAPI Spec 3. And just a note that we in the presentation will be using the word Swagger a lot, and that primarily we're referring to the specification that is OpenAPI 2.0. But recently, I think last week, a couple of weeks back, OpenAPI 3.0 was finalized as well. So just keep that in mind. So when we say Swagger, it's primarily OpenAPI 2.0. Okay, so what is mocking and what is sandboxing? Well, first of all, mocks, if you are working with APIs, you have come across very basic mocks. If you are working with Swagger specification lets you define certain examples of your responses, and there are tools that would enable you to come up with responses and then give it to your consumers. So mocking is a very static and a very code-driven way of representing your APIs and giving it to your consumers, or maybe using it for yourself for your own purposes. Like if in case you are developing APIs for your own software, you might go in while you're writing code and you might hard code certain responses, right? And that is also mocking. And there are certain libraries, an open source tool, SoapBear open source is used a lot for mocking, and mock server is another example which is used for mocking. These are very script-driven, code-driven ways of doing mocking, and a lot of technical knowledge is required to know that how to create any level of sophistication in the mocks. Other thing that people use is sandboxes. So what sandboxes are primarily provided to you if you are an API consumer. An API provider would provide you with a sandbox. And the problem with sandboxes is, again, that this is from the point of view of the API producer. Maybe if you are hitting or trying to consume an API from a payment gateway, the payment gateway people will give you a very static set of responses for your purposes, for your development purposes, which are not always enough for you to work, because they have thought of it in their way, but you are consuming it in a separate way. You might be looking at many more scenarios beyond what the producers of the API thought about you. So they are limited. They're pre-provisioned by the producers, and they're very, very much specific for certain use cases. Yeah, so these are certain specific problems that you would face with mocking and sandboxing, and we see these problems come up when we talk to our customers and our community members. Mocks are very hard to create. They need a lot of scripting experience. And other problem with mocks is that they are very much static. So mocks are, they just give you one single response every time because they're hard coded, and it's very hard for you to make them dynamic. Because dynamic, what I mean to say is that when you are testing or using or consuming APIs, you just do not want one, for example, you do not want one item to be responded every time. You may want to test many more different types of item if you're developing an e-commerce application, or if you're doing a library application, you do not want just one book. You want to try out different scenarios, different kind of situations of responses from your APIs. So it's very hard for you to create those kind of multiple scenarios using mocks. And what mocking and sandboxing does is they provide you a very, very high-level idea of an API. Like if I look at one response, I just get to know, okay, well, you know what, this API gives me a response for a book. But what happens if, in case this API is under a lot of load? What will that response look like? Will it give me an error? What is going to happen in that case? And what will that 400 error look like? I know it's going to give me a 404 if it's not available, but what will the JSON and the body look like, right? And if I want to do some thorough consumption of this API, if your consumers really want to build cool applications on your APIs, they need to know those in-depth scenarios. So mocking and sandboxing do not provide you that kind of in-depth scenarios. And other problem is that these are mocking and sandboxes. They are very stateless. And when I say stateless, essentially the problem is that when you are testing or consuming an API, you want to consume or test a whole scenario. And often you need a state with the scenario. Now, for example, if you're testing an e-commerce application, then you have to have a bunch of user information for that application. Like, for example, their login credentials. You need to have their name. You need to have their ID. And you want to pass that information across all the responses and requests. And mocks do not enable you to do that. Unless you are really good in coding or scripting, you can do that using some specialized mocking frameworks. But then the amount of time it takes you to develop that and expertise that is required is immense. And there is no easy way to do that through mocking and sandboxing. And with sandboxing, it's out of your control. You can't call up the people who are producers of API and tell them that, can you please make my responses more stateful with the information that I have for my consumption. So yeah, so in summary, the mocking and sandboxing do not cover more than one or two scenarios, and they are stateless. And it's very hard for you to kind of emulate situations like I want response A and then I want a different kind of response in the next request, right? So if you want to do more sophisticated routing between different responses, it's very hard for you to do that. So coming back to our discussion around Swagger design work. So if you are a Swagger developer or a person who's designing Swagger specifications, what happens is that once you have done writing your initial Swagger specification, and if you want to make a version of that available to any of your consumers, that could be developers or testers of your application, it could be your end customers, it could be your clients, it could be your end users. To do that, you have to go through certain stages. For example, if you have to give that API, which is in some way more responsive, it's some way more dynamic, then you have to write code to make that dynamic. Unless you do some development around it, it's very hard for you to give that API to your developers and testers, because with just mocks, they won't be able to do much. With sandboxes, they won't be able to do much testing or development on your APIs. And if you're giving it to your customers, maybe you are a consultant and your customers have asked you for a set of Swagger APIs, right? And they're saying, I just want to take a look at what you have done and I want to give it to my developers so that they can actually do some amount of testing and see if it fits with our frameworks, right? To do anything of that sort, you have to write all the code and test it out before you give it out, because you want to make sure that it is at least of some level of quality before you give it to your end consumers or your customers who are paying for that. And of course, if you want to do some user testing, maybe you want to do some prototyping of your applications, right? And you want to do some beta with your customers and end users, then you have to develop an API and deploy it in production. You have to make them available on a network. And with mocks, that's very hard to do. You can't even change a response. Forget about putting it on a network and making it available maybe over cloud, so that your different customers or API or your consumers could use it. So with the mocking and sandboxing, to make your APIs available, even make them even usable to some extent, consumable, but even some extent by your consumers, you have to go through this development, testing, production cycle. And once you go through this, after that, some feedback flows back to you as a developer and designer. People will say, okay, I consumed your APIs, which you had deployed in production, and you know the problem is that one of these parameters are not working. So you go back, you again modify your specification, and you again do the development, testing, and production cycle, and then another piece of feedback comes to you. So it's a long process, and we wanted to think about ways of short-circuiting it going forward. And we will, in future slides, you will see how service virtualization helps you short-circuit this process. So before we tell you how that happens, we just wanted to give you a little bit of introduction to service virtualization. So what is service virtualization? Basically, it's a way of accurately mimicking or simulating behavior of components which are unavailable or difficult to access during your software development and testing processes or anything beyond that as well. So we are talking about APIs here, but service virtualization is not limited to APIs. You can virtualize devices, you can virtualize databases, you can virtualize networks. So there are a bunch of other components which could be virtualized, so that if in case you are working on any software and any of these type of devices or databases are not available, you can use service virtualization to emulate them. Device virtualization is very popular, especially when you're developing a mobile phone application. You need to have these emulated devices on your desktop so that you can test them. And there are a lot of companies which provide labs of these devices. SmartBear has cross-browser testing as one of the applications that we provide that enables you to test your single application across multiple devices. Similarly, databases, it could be possible that you are not able to emulate the production database for your testing and development purposes. So service virtualization helps you emulate through some JDBC transaction recording and replaying, so that you can actually test and develop off of that. APIs, we're going to be talking about it in the future. So this is just a general overview of service virtualization and the way it helps you in your software development and testing process and beyond. Putting virtualization in perspective with mocking. So, well, we talked about mocking and the problems with it. Virtualization kind of fixes all of those problems. So mocking is static, it's implementation. Virtualization allows you to mimic those services very, very close. So it's almost like a full implementation, and it is much more in your control, right? So because virtualization solutions enable you to quickly replicate scenarios, it enables you to quickly develop routing procedures between different responses. So and you can do it yourself with just a few clicks. So it's in your control, and you can develop any virtualized scenario for your software development purposes. Mocking, of course, is stateless, passing different parameters between different responses, but virtualization is totally stateful. You can do whatever you want. You can set up the context around it. You can set parameters that can go around in all the responses. Mocking is it's almost 100% manual. You have to think about it. You have to write the code from like the hello world stage and grounds up. But with virtualization, most of the solutions are pretty much prepackaged. You just have to install them, and then you are just up and running with the solution in just a few minutes. You will see how easy it is with our Service V solution to kind of get up and running with Swagger APIs. And finally, mocking is you cannot reuse what you have done, right? So once you have done one mock, you have to think about how you can efficiently replicate that. If you're doing it in a code, you will just keep on copy pasting code in different classes and different methods and functions, and that's not a very good way of doing any kind of software development if you are looking at maybe hundreds of scenarios and thousands of scenarios. But with virtualization, we have the capability of taking one scenario and then replicating and cloning it and modifying it with a few clicks, even automating it. So it's very easy to do that in the virtualization. So these are the primary benefits that you would see with service virtualization. Well, of course, it's going to save you a lot of time, and down the path it will save you a lot of money, because you can very quickly create, edit, and the virtualization responses for your Swagger APIs. It's very easy to do. creating these mocks is very easy through different ways. You will see in the demo in just a few minutes how you can very easily create those mocks through the specification, recording them, and then you can use it for any purposes that you have. You can just put them on a network so that you can give it to your consumers, right? Your customers maybe, and say that this is an endpoint I've installed on AWS. Why don't you use it for your purpose and let me know what's the feedback on my design. If you ever need to go back and change certain things, and they would come back to you very soon. Virtualization makes your mocks very realistic. So that's why we call this whole webinar advanced mocking, because it takes this concept of mocking and then makes it really advanced and sophisticated, and that's when you get into the realm of virtualization. So these services in service virtualization are realistic and real life because they are linked to certain dynamic parameters down below. So for example, if you have a response as a JSON and it has a field that is an item, you can link that field item to a column in the database so that real data from a database is being picked up and being responded. So I think this is a big part of design, because when you're designing a Swagger API, it's not just you want to design the specification, you also want to design which kind of data do you want to respond with, right? And then a lot of times you would do it with capturing different kind of responses and scenarios in an Excel sheet or a database, but with virtualization you can link those scenarios that you have thought of to your actual design specification and then make them work like an actual API and use them for your whatever purpose you have envisioned using them. Other value is that you can very easily route, once you are done with your testing on the virtual services and you want to point it to some actual service, if you have them already up and running. Maybe you are iterating on a different version of your Swagger specification and your old version is already up and running. You just can route to the old version with just a few clicks. And then, of course, you can take all of this and share it with your teams over the network and or the cloud. All right. So here is the culmination of whatever we have talked about so far and how it kind of ties into your Swagger design and development. I'll just walk you through the process and you'll get to know that how it makes your life very easy in terms of using and designing and developing better and better APIs. So when you have your Swagger API, and then you can import them very easily into a virtualization solution. Here we're going to use Service Pro, and once you have created these virtualized APIs, link them to data, they're ready to go to your consumers. You can give it to your testers, developers, managers, your customers, and then these people can use them. And then they can come back to you with their feedback and tell them that, okay, this design really looks good to me, or maybe I have certain problems, this doesn't fit, this response is too big for me, or you know what, your API is not responding in a certain amount of time, and because of that I have issues with my software. So you can emulate those kind of latency things with Service Pro. Once you have that feedback, you can go back to your drawing board, you can go back to your design and kind of improve it. You might say that, okay, you know what, my response has 20 different elements and out of that 5 are coming from a database. And that latency, because the database is causing problems for my customers. So I might do some kind of changes on my infrastructure when I'm going to put it in production. I might put like a cache or something if that's the problem. So you can emulate all those scenarios beforehand. And all that feedback goes into your design and documentation of your Swagger immediately. And once you have changed your Swagger specification based on the feedback, you can take it back to Service Pro, easily refactor the changes into your virtualized APIs. And then again, give it back to your customers. And then they come back to you again with some feedback, or maybe if they're happy, you're like, okay, I'm done. And then you can just move it then to development and testing phase. So what has happened here is that all of your design process has been short-circuited. Your feedback comes to you earlier. You have not written even a single piece of code before you have finalized the design, before you get all the feedback from your consumers. And you're able to do that cycle as many times as you want, because just importing this API into Swagger Service Pro and then refactoring it, it's very fast and quick. And you will see all of that when we do our demo very soon. So you end up saving a lot of time. You don't have to go through the entire cycle of development and testing before all of this feedback flows to you. And and the result is that you design better APIs and down the line save a lot of money in terms of development and testing processes, because you're not doing that process again and again. You just do it once you're final with your API design. And it also helps you connect better to your consumers, because they know that your APIs, how do they perform each and every version. They might tell you that, okay, your version 0.3 was really good for me, and I think you should revert back to it. So you have that kind of feedback. And once you have that, you go and commit to your testing and development dollars. All right, so now I'm going to pass the ball to Nathan, and we talked about a lot of things. We talked about how you can import your Swagger specification. You can create these sophisticated virtualized APIs, and how you can iterate upon it again and again, and how you can share it with your team and your customers and users. So he's going to show all of that.
Great. Thanks, Hush. Once again, my name is Nathan. I work over here at SmartBear as an engineer. I think the slides covered it really well, like the benefits or why we want to start virtualizing in the first place over something like mocking. At the front, obviously being able to add logic in is kind of a crucial thing, but I think what really is going to hit home today is how tightly integrated with that design document these virtualized services can be. So as we make changes, as we update, it's not an afternoon of kind of refactoring and coding. To make these switches, we can really just use a couple of clicks to kind of update these virtual services that we're going to create today. I think it's a really nice way to very quickly iterate over kind of something like an API design. So just minimize the slides here, and we're going to get started today in Swagger Hub. So I imagine most people kind of watching today are familiar with Swagger, not necessarily familiar with Swagger Hub, so just a 2-minute kind of intro here. This is our design and API documentation tool. It's built on top of Swagger, and it's a great way to kind of work in a group environment to create these Swagger documents. So we see it as a collaboration tool. We see it as a design and documentation tool for RESTful APIs. I personally think it's a terrific way to write these Swagger specifications. Just as a couple of notes, I mentioned that there's a really nice way to collaborate within the tool. A couple of the other kind of really cool features, the ability to do live documentation. So here on the right-hand side of the screen, I've got essentially a version of the documentation that will eventually be published, will be viewable to the API consumers, and it's bound to the information on the left-hand side or the design document that I'm creating. We can open any of these up. We can kind of get some more info about the API that we're building out. Things like these default values or example values, these can all be included. I can update them in my documentation. We'll see them reflected here for the consumer. And we can then take this and kind of bring it into something like a service virtualization tool. So really, really dynamic, really flexible. I think it's a really neat kind of platform for building these Swagger specifications. But if we're being honest, it does have its limitations, right? Within the tool, we do have an auto mocking feature. We can take a quick look at that. It's turned on in this example. We can generate a kind of a URL here that we could take and start to potentially run some queries against it, and immediately we're going to see some of the issues that we have with this. If I type in some different IDs here, it doesn't matter what the value that I'm passing in, I'm getting the same response back every time. And it kind of exactly what Hush was saying a few minutes ago, it doesn't really serve up what I want to my API consumers. I want them to have not a true representation, but a pretty good representation of what the API is going to be capable of. So different values coming back, different formats, just being able to kind of play and define, a little more closely with the actual thing, what this API looks like at a much earlier stage, I think is really crucial to what we'll be covering today. So auto mocking, great for very, very kind of early stages of playing around with these definitions, but if we want to take it a step further, we want to actually start sharing, these quote-unquote early APIs with much larger groups. We need to have some kind of extra logic, and that's where our tool Service V comes into play. So we'll go ahead, we'll start virtualizing this API here. And we're going to jump into Ready API, another tool that we built here at SmartBear, and I won't go into this, super detailed specifics of what we're capable of within this platform. Suffice to say, it's a very, very powerful API testing tool, an API-specific testing tool. So today we'll define from a Swagger specification a project. We'll bring that into Service V, our service virtualization tool. We'll look at some of the different features, how we can add some logic on top of this virtualized service. how it can essentially listen for specific requests, serve different responses based on that. We'll talk a little bit about behavior, how it can modify the behavior of these virtual APIs. We'll hook it up to a data source, so actually add some variability in the responses. Something like a session ID we can very quickly recreate. And then we'll take a step further. We'll make some changes to that Swagger specification. We potentially get some feedback from our consumers who've been playing around with this. We can very quickly update this virtual service, push that out, and finally we'll kind of wrap up with deploying this to a shared environment. So not just hosting this and running this on my local machine, but actually moving it to a space where developers, testers, consumers, everybody's going to be able to interact with this. I could take feedback, continue to iterate, continue to design, and kind of keep pushing new versions out to this shared space or kind of a shared server that we'll get into towards the end of the presentation. As it stands, again, just a quick note on Ready API. Testing kind of platform that we build here encompasses most of the aspects of testing within the API space. Functional testing is done in SoapUI, a very popular tool that's out there. We can take any of these functional tests that we develop, bring them into a security testing space using a secure module. We can also bring them into a performance testing space, which is LoadUI. So we can reference these functional tests, we can bring them in, run them at scale. There's a lot of ways that we can start to pass data between the tool here under this kind of Ready API umbrella. But enough talking about it. Let's go ahead and jump in to the platform here. So we'll get started in the Projects tab. Essentially, to begin, we need to define the API interactions that we want to have, and to do that, we're going to import our Swagger documentation. The document that I wrote is pretty straightforward. It creates, or it's designed around kind of a sample library where I can query against a single resource in books and get kind of an array of information back, all of the books that are available. But then I could also query a specific ID. So books-ID should serve me back a specific single book based on the ID that we're kind of sending the resource path. And we'll get into some different parameters as well and how we can listen to those. But we'll go ahead, we'll get started. And from this point now, I've got this new project. We'll just give this some kind of unique name. Swagger library sounds good to me. Now, we can add the Swagger document. We're going to import this. And for those who aren't familiar with the Swagger Hub tool, right now we're kind of seeing this in the browser, obviously. But as opposed to this, I can actually utilize an API that's exposed, and it can serve back Swagger specification in a JSON format. So this is what we're going to use to import into the tool. So right now we're reading this we're making a call to the Swagger API, getting this document back. We'll see, as I kind of iterate on that design, we can continue to update this by using that API. I think it's a really, really cool way to link this up with something like Ready API. We'll just click OK. Take a second to import this definition. And we can see now on the left-hand side, again at the project level, we have defined all of these different resources, all of the different methods, and this is being pulled right from that Swagger document. Again, my different resources, the one we'll focus on today is this books-ID. Essentially, how can we not just get the same book object back every time, but we can actually get something that's different based on the kind of query parameter. So we'll go ahead, and from this point, we'll right-click and generate a vert. And this is going to bring us into Service V. I just want to make sure this runs on a kind of a unique port. Pick and choose the different resources, methods up here. We'll bring all these down, give it a unique name if I wanted to. But very, very quickly now we can see we have this virtualized service built out. And just to kind of talk a little bit about the structure of the tool here, on the left-hand side we have the methods, the resources that we're going to be querying against. So these are the kind of the incoming requests that we're listening for. On the right side of the screen we have some different responses. And these are going to be pulled directly from the document that we defined. So I had a 200, I had a 404 response defined in each of those resources and methods. In my Swagger document, we can see that that's been pulled right into the tool here. So there's very little setup that I have to do by creating that, well thought out and kind of deep design. It's going to hook up really nicely to our Service Virtualization tool. So we can see here I've got a couple of methods for books. With this books-ID, We've got a couple of different responses here that are defined, and this is what we want to make dynamic. So right now, we'll set this running. We're listening again for these different kind of requests coming in. We can take a look at this on the browser. Essentially, I can query against this localhost 8065 running on port 8065. We can ask for books. We'll get books. We can ask for books -ID. We get an ID. And right now, this is set up to just kind of go through a sequence of the responses. So we can see we go back and forth between the two. It doesn't really matter what the ID that I pass in is. You know, we're going to keep kind of cycling through. So a little bit of logic here, but not really what we're looking for. This value should match up with the ID that we're sending back. So why don't we jump back into Service V, start actually building out that functionality. To make this a little clearer, I am just going to rename some of these. So we'll bind this to the actual ID that we're going to serve back. It's 105. And here we'll say this is the 404 message, so we'll just rename this to 404. Now, to actually layer on some logic, we're going to talk about the dispatch style here. So this is essentially how we choose, based on the request coming in, what response we want to send back from within the tool. Again, this right now is set to sequence. Random is pretty self-explanatory. We'll just pick and choose the responses at random. Query match XPath, that's more with kind of XML or SOAP services, so we won't get too far into that today. The script one, I'll just talk about very briefly. Within the editor here, we support Groovy scripting. If we had something very specific that we needed to do, or we wanted to add some really dynamic properties on top of this virtual service, we can build out some pretty flexible scripts. Do things like maintain HTTP sessions. We can do things like recreate or simulate the way the cookies work. Do all of that through just a handful of lines of kind of script within the editor here. Today, we're going to use this parameter option. This essentially lets us define a set of rules that say if this value is in the request, then send this response back. At this layer, we can define a default response as well. So if we don't know how to handle a request, we're just going to send back a 404. Right now, we've already created something a little better than a mocked API. You know, now if a request comes in that the tool doesn't know how to handle, we have a response, a default response sent back. So just a very kind of basic piece of logic, but I think a good initial step and a good example of where this really sets itself apart from something like a mocking tool. Now, we have a single response here for the ID equaling 105. So we're going to add in a new rule. We're going to listen for the path, the ID. If it's equal to 105, then we'll send back that response. So pretty straightforward, you know, very kind of high level, but I think, again, you know, creates that level of kind of logic here that is really powerful. We'll rename this to be bound to that ID. And now we can run queries against this API. We can send back a specific response based on that kind of ID that's coming in. Let's take this a step further. Let's, instead of just having this single response defined, we'll recreate a couple of these. So we'll say ID is 106 and ID is 107. Now we'll just play around with some of these values here on the right-hand side. So just recreate. You know, been reading the Game of Thrones book recently, so kind of stuck in my brain. 6 and here we go, 107. Anyone remember the name of the third book here?
I do not.
Okay. Feast for Crows. Thanks, Mike. All right. That'll do. All right, and we'll just give this one 107 as well. So again, kind of updating these IDs to match the values that we're going to be kind of querying against. And very quickly, we can just recreate some of these rules. And we listen for the ID equal to 106, send back 106. And here, ID 107, send back 107. Great. So 3 rules. We have a default response. Now, everything happening correctly, we should be able to hit this. with some of these different values, we can see here 4, 5, don't know how to handle those, so we send back that 404. But 105, we get the ID back. 106 now, we get 106 back, and 107, you can see we get 107 back. So very, very easy to do. No scripting. I think all I did on the keyboard was just enter in those ID values, and we've already created this, this kind of stateful, stateful virtual service. So we're listening to the requests that come in, and we're serving back responses defined by those requests. This is kind of a basic example, but we can really take this a step further. These values that we're querying, if we had something like a username or a session ID in this path, we could serve that back in the response. We can take these values and kind of send them back. We can pass them on to something like a database or a data source. We can store them in some kind of virtual property or custom property that we have to find. We have a lot of depth and a lot of flexibility within the tool, beyond just creating this set of rules and kind of serving back responses based on that. So a quick example, but I think a pretty cool one here.
I love the fact that it's been just 10 minutes into the demo and you have been able to create a very responsive set of APIs from just a Swagger definition. So this did not exist before. It was basically a definition, and now this is something that you can easily share with your consumers, and they can use it for whatever purposes they want to. And if you are a consumer of a Swagger API, you can just take the definition that has been sent to you by your contractor or your consultant, and you can just create all these dynamic APIs for your consumption.
Exactly. I think that's a great use case. Maybe I have access to the Swagger specification. I can import it. I can play around. I can test against it. We could potentially even build out some functionality in this virtual service that maybe we don't want to move into that design space yet, but I want to see how it works. I want to see how my kind of front-end application or something integrates with some of these new kind of features. We could build that out in the virtual space and then kind of get some feedback, see how it works, bring it back into the design document, build it out a little further. This continuous iteration, I think, is the key to kind of a good design, and it will make things much easier down the line. Once we have an initial kind of published version, we've got it with the dev team. We want to continue to iterate. We've got a great platform to be able to do that. So I know we've got about 15 minutes left, I think. Do we wrap up at 10? So I just want to show off a couple of the other features here within the tool. Right now, I send a request in. We serve back a response pretty much immediately. This isn't a very good representation of what the actual service is going to be. Typically, this is going to be running on a server that's going to have some kind of latency in the time it responds to me. Potentially, there's kind of a limit to the scale that server can handle. Within Service V, we have control over that. So the Behavior tab here, we can define things like the connection bandwidth that we're looking to simulate. We can define specific capacities, the max, min number of threads. We can add something like latency with just a few clicks here. Now, even while this is running, we can send a query. It's going to come back in slightly less time, so we could kind of mirror this to what the actual kind of production version was going to look like. Again, give a better representation very, very early on of how we'll be able to interact with this API once it's developed. So a really kind of small piece, but I think a really cool piece for mimicking the actual services. Just the other tabs up here, transaction log, exactly what it sounds like on the box. We get a specific query in, we send a response back, we can analyze both of these through this virtual service. This is really handy for debugging, kind of seeing what might be going wrong with the requests that are coming in. We'll talk a little bit about data sources. This is pretty much how we pull in information from an external source. So why don't we show a good example? I talked a second ago about kind of building out some new functionality. Why don't we try doing that here? We'll do this on the fly and see how this goes. So let's say we've got this books resource, and in my Swagger definition, I query books and I get all of the book objects back in a single response. I want to have the functionality where I can get a random book back. So instead of just giving me a single kind of response or kind of sending back this array of information, we just pull a random book from that object and send it back, or from that array and send it back. So to do this, we'll build out a new response here, and I'm just going to copy and paste one of these values down that we previously created. Find this as JSON. And now we're going to add some variability in here. So I think a good example of this would be something like a travel guide. You know, we have a new city that we want to send back, and we want to simulate, you know, this travel guide kind of value changing each time. So what we'll do, we add some variability with the ID, with the title, and with the first name and last name of the author here. So we'll just show this in action by going over into our data sources, and we'll have the tool spit out these values for us. So to get started, we need to create a data source. This tells the tool, okay, we want to create some random values, or we want to hook up to something like a database or an Excel sheet, and then we need to just start defining the properties for the values that we want to generate. So I think I said ID, title, first name, and last name. And now within the tool, we have a couple of ways that we can start to pull information in. An Excel sheet, going to hook up to a spreadsheet, pull in information from there. JDBC data connection will hook up to something like a local or remote database. This data generator is kind of a neat one. We can essentially define within here some random values to be outputted, or the tool can output these random values for us. So here, this ID is going to generate a value between 101 and 999. The title here, we'll just pick some random cities. The first name, we'll just have the tool create some random names, and we'll say first name. And then the last name here, we'll do the same thing, but with last names. There we go. Great. So now I've got all of these properties defined. How do we bring them into the response? Well, to do that, all we have to do is say what data source we want to connect to. So we can only have one per response. But from within here now, we can start to pick any of those values that we're generating from that data source. So the ID, we'll navigate down and select the ID here. Remember to wrap these in quotes. The title, let's import that title, and we'll say whatever the city is, a great place to be. And finally, I said that we want to change the author name. So once again, get data. And then again, I'm just referencing the properties here that we defined in that data source. So all point and click information, the tool is going to do really the legwork for us here. I just have to point to those different values. And then finally here, we can show we can utilize things like these properties within something like a resource link. So now this is running back in my actual service. We'll rename this to be that random response. And I just want to define a rule here. So by default, we'll send back the first response, and we'll say if we get the query random equal to true, then send back that random response. So this is some brand new functionality, something that is not defined within my documentation, within my Swagger document. I want to kind of test it out here in this virtualized or this localized environment. We're using some random data, but I want to do it kind of at a very early stage. And we can do this now. I should be able to go in here. We query for books. We can see we get that single response back. But I can pass in the parameter, remember random equals true. And now we get some unique values back. So we can see the ID, the city name, all of the kind of first name, last name information. This is being generated every time I send a new request. So pretty basic example, you know, potentially not particularly useful, but it's already giving me an idea of what this kind of random functionality is going to look like, and maybe now I can move into my testing space and kind of start working on some tests that are going to, you know, accept these random values, and we'll be able to handle it. We can create some dynamic functional tests that are able to handle this kind of information. Really, really cool, and again, nothing that I had to do script side, no code that I had to write. It was all through just a handful of kind of point and click interfaces, a couple wizards, and that one data source. So I think it's a really nice way to kind of go from design to an early stage of implementation, work within this space, move back to design, and kind of iterate through. We've got a few minutes left here, so I'm just going to wrap up talking about one other action, which is the ability to kind of update these virtual services. Before I do that, I kind of want to show the capability to share this with the rest of the team. Hirsch, I don't know if we want to see if there's any questions that have been coming in before I do this. I'm just going to move on to Virt server and then.
I think there are a lot of questions coming in, but I think we should take some time later on before we end the webinar to answer those questions collectively.
Okay.
That makes sense.
Yeah, we can move on to those in a little bit. Great. So before we add some new functionality here, I've got a version of this API that I want to share with the rest of my team. I don't want to, be kind of playing around with this and have them try to run queries against it. That seems to me like a recipe for some headaches. So why not push this to a shared space that they will be able to test against, and I can have like this local version that I'm able to continue to work on, continue to iterate on, and then continue to update that shared version. So to do that, we're going to lean on another SmartBear tool called Virt server. Virt server is a program that's going to be running in the background of my local machine, but this could be running on a server within my network or on another machine within my network. Essentially, once it's up and running, it's going to be discoverable from the menu down below, so I could connect to multiple Virts here if I had them available. But all I have to do to take this Virt that's running locally and move it into this shared space is just click and drag. And now we have this version of this library Virt. It's version 1.0 essentially, and instead of it running on my local machine, it's now going to be accessible. We can see here on the right hand side at this URL. So I could start this, I could share this link with the rest of my development team, with my testing team, QA team. They'll be able to interact with this virtual service, all the same functionality, the behavior, the data sources that we've created, all of that's going to be pushed to the shared space. It's just going to mean that I have a version now locally that I can continue to iterate on and not touch what they're actually utilizing in that shared environment. We'll set this running. This is set up so anybody could really query against it. Hirsch, Mike, the rest of the team here, they could start to interact with this. I have a level of control over this within Ready API, but I should point out, if you are interested or this does seem like a useful functionality, we actually have some pretty cool tools built on top of Virt server, one of which is our web UI. So now within this web interface, we have a way to start and stop these virtual services. We can record things like the transactions that are going on. We can start to update ports if there's some kind of issue. Generate reports from a very high level. So we want to see, maybe this is shared in like a sandbox space, and we want to have people testing against it, consumers potentially utilizing it. I could generate some reports and see, what are they doing, why are they doing it, and what kind of queries they're sending in. This is going to be a really nice way for me to get some feedback from those consumers without having to, send emails, ask, try and talk to them directly. We can just kind of see how they've been interacting with these virtual services, potentially help guide me in where I need to make some changes, updates, where I can kind of potentially spend my further development efforts down the line. So just a quick example, now this is running in this shared space. I have this local Virt that I can kind of continue to iterate on. And to do this, I'm going to move back into my Swagger document. As an example, what we're going to do is we're just going to create a new resource, we're going to create a new method here under one of the resources I've already defined. In this case, we've got this get authors kind of method and resource, but why not add in a delete method as well? So we'll just copy and paste this just as a simple example. Copy this down, tab over, and just define this to delete. We should see this get updated in just a second. There we go. So now we've got some new functionality. We've got this new method against this resource. From a design standpoint, it fulfills my requirements. I like the look of it. I'm pretty happy with it. And I want to move it again to this virtual space where I can actually start testing against it. To do that, once again, we have to kind of query the API. And we have a really nice relationship in Ready API and Service V for updating Swagger documents. All of these things fall under the SmartBear umbrella. So I think that we do a really good job of kind of integrating our different tools with something like the Swagger specification that we maintain as well. As an example of this, I can just re-import or update this definition that I created with that new version. It'll pull down that information from Swagger Hub. It will even take that, push it into the virtual space. So we can define here, add new methods to Virts, for example. Click OK. Now, under this authors option, we see we had that delete method that wasn't there before. Back in Service V, we had this delete method that wasn't there before. I can set this running. Again, run some tests against this. Let's just update the port. We could run some tests against this from that local space. I could build out some, some dynamic properties here. Do exactly what we just did over the last 20 minutes or so within my local space. And again, push this to now a shared environment. So we have this new version. We can click and drag it down. We do want to replace. We want to update the existing vert. We can see it happen very, very quickly, very smoothly. Now I could start this service again. Everybody else in my development team is going to have access to that new method. Start building tests, start integrating it with our front-end applications. Really, really easy, and I think that took under 3 minutes to do. There's such a nice relationship between that Swagger specification and this local vert and the shared vert. I think it's a great tool for early in the development lifecycle, and a great way to iterate as we move through kind of different stages of development, and we continue to get feedback. As Serge mentioned, we get feedback from everybody, and I think this is a really nice workflow to kind of implement that feedback into the tool. So that pretty much covers, at a very high level, some of the core functionality of Service V. The tool goes much, much deeper. We could have done this all from scratch. We can record and store transactions through this tool. This is just one example of how we can utilize Service V and Swagger together. Hopefully it's been useful, and hopefully given some people some new ideas, and pointed out how we can take mocking, which is a great kind of early stage thing, and take it a little step further, how we can move it beyond just those static responses, add some kind of dynamic information and layers to it, and hopefully make it useful to a much wider audience by kind of sharing it in this Virt server environment. So I guess now that covers that. I guess any questions that have been coming up? Have I left everything?
A lot of questions have been coming up, and Mike has been doing a phenomenal job of responding to them immediately. So there are some which kind of which strike out as very important questions. Like there's a question by Miguel, and he's asking who typically creates these virtualized tests and mocks, whether it's developers or is it are these other people? Who are the typical consumers of this software?
Yeah. So there's the consumers. We find developers who are writing kind of a front end that's relying on this API. They will be a great kind of person or a group who would want to utilize something like this. QA team, I think, is kind of the biggest base that we see utilizing these Virt services. Instead of sitting around, or not sitting around obviously, but instead of waiting for the API to get to some stage in development where they can build tests against it, they can develop those tests much, much earlier on against this virtual service. And when the actual API comes online, we can just repoint, and to plug shamelessly the tool, we can repoint something like Ready API to that new deployed API, and we can just run the same tests against it. There's going to be no latency. There's going to be no delay between kind of going from development to QA and to testing.
Great.
Yeah.
And there's a good question from Thomas, which is about sharing of these words. And can these words be versioned, and can other developers pull these words down and use them locally?
Yeah, no, that's a great question. So from Virt server, we're not going to be able to pull down the Virts. We can't like copy and paste them into a local environment, but we could share the project. So within Ready API, we can move these projects into something like a repository or a shared space like GitHub or Bitbucket. We can then have a group of people kind of who work collaboratively on these virtual services. And they could pull in those projects and kind of stand those up locally from there. So as far as versioning, we can absolutely rename these in the kind of shared space to certain versions. We could run them on different ports for different versions, that kind of thing. We can potentially have multiple of these running at one time, hundreds if we really wanted to. So yes, it's definitely capable.
Awesome. All right, so we have a lot of questions coming in, but we are already over time for our presentation here. So you will get a chance to ask for more questions down the line when you end the webinar. If you have any feedback, please provide us that. I just wanted to close the webinar by doing a little summary and just reiterating the fact that please think beyond mocking and sandboxes. Know the limitations of mocking and sandboxes. If it's working for you, it's great, but often if you're doing a realistic scenario for your consumers, it's often not enough for consumption of these to create these sophisticated APIs on Swagger. On the flip side, service virtualization, which we introduced the concept to you, it enables very real-life APIs for iterative design. Always remember that it's not just about giving realistic APIs; it's also about saving that time and money in the end, and committing to development only when you are sure that your API design is right. So there are some values that Service Pro brings to you as a virtualized solution. It's very easy to use. As you saw, there was not even a single piece of script written by Nathan. No, anybody can do it. Like anybody, like managers, to use Service Pro to create mocks and then use it for their own purposes, to do demos and create prototypes. It's very easy to use. It enables you to do a lot of dynamic responses. There's no experience required with coding, and you can share all of the awesome work that you do with virtualization with your team. So with that, I'm going to pass the ball on to PJ for some closing comments.
All right. Well, thank you first to Mike, who's been answering questions in chat, and Harsh and Nathan for running an awesome session. And we'd like to thank all of you, excuse me, for joining us today. We'll be sending out the webinar recording later this week, so if you found the session interesting, please don't hesitate to share that with your teammates. In addition, if there are any questions or comments that you have for us that we weren't able to get to, once you close out of the webinar, there will be a submission box where you can submit those questions, and we'll be sure to follow up with you following the session. So with that, thanks again, everyone, and I hope you enjoy the rest of your day. So long.